Hi and welcome to Decarbonize and Energize. My name is Adam Ritzen and I'm working as business developer at WOW Group. At WOW, we are passionate about cleaner oceans and lower CO2 emissions. And Decarbonize and Energize is just about this, how we can turn waste into valuable resources and energy in order to support the circular economy. There will be a series of webinars with different interesting topics, so don't miss them and stay tuned and sign up for them. And of course, welcome.
Hi, yes, thanks Adam. Hi everybody. So I am Philippe Pugeron, I am Deputy General Manager of Etia and I'm very happy to be with you today for this second webinar, Decarbonize and Energize. So last week for our first webinar, Anna Groszowska, our Sales and Marketing Director, presented our group WOW and also how to turn biomass into value with renewable energies and bioproducts with high added value like biochar or BIOCOAL. So today I will focus more on how to turn waste into value. This waste can be biogenic like sewage sludge or not like plastics, but we will see during this webinar that in both cases we can get some very interesting environmental benefits from our solution. So to begin with, I would like to underline three main elements about valorization of waste. And we will go after through 4 business cases to illustrate these elements. So let me share my screen and the presentation with you. So first, how to develop a circular economy with a good valorization of waste. So a very good example of that, of circular economy, is a cruise ship. Actually, on a cruise ships, there are thousands of passengers that produce as much waste as a small or medium town. And these cruise ships are under big constraints in terms of space, very limited capacity of storage, a high level of safety and availability. And so they are also requested to be more and more efficient in terms of energy and waste management. It is precisely the challenge that Scanship has solved. And the solution to do that is a mix of solutions, a mix of technologies with filtration, drying, sorting, incinerators, anaerobic digestion, and pyrolysis. Scanship offers to its clients a global integrated solution with a portfolio of these technologies, including a pyrolysis technology named MAP with microwave. For land-based solutions, it is very similar. The capacity can be bigger, and it is where Etia intervenes. So first important element to be noticed, the solution for circular economy is a mix of solutions, among which pyrolysis. Second point, there are different ways to valorize waste through thermal treatment with 3 main technologies. The first one, the main known, is incineration with a complete combustion. The objective is above all to eliminate the waste, mainly the household waste, with a lot of heterogeneity. So it produces hot fumes, and these fumes can be valorized as heat or steam, and after, for instance, with a steam turbine to produce electricity, but with a low efficiency. Another possibility is gasification. Gasification is a partial combustion. The objective there is different. The objective is to produce energy with a porcine gas because we use some air and so nitrogen. This same gas can go after purification, can go into an internal combustion engine that will get some higher efficiency. And last is pyrolysis, where there is no combustion. With pyrolysis, the objective is to go up to chemicals, to split the feedstock into different products, a rich gas, a liquid, and a solid, with different proportions depending on temperature and dwell time. In the old days, I find it very interesting to notice that the pyrolysis of wood was named distillation of wood. That is the idea, to separate the different phases to give them a maximized value. So with pyrolysis, we can also produce heat, steam, and electricity, of course, but also some molecules like hydrogen, methane, and bioproduct with a lot of value. Incineration addresses more big capacity with heterogeneous waste, when pyrolysis will be more in a circular economy with more specific waste. Pyrolysis allows also to reach higher values with the products, and last but not least, to help to reduce more significantly the carbon footprint. So second element to be noticed, pyrolysis is key to give more value to waste. And this is done through business model. As pyrolysis gives a lot of flexibility, we can choose the business model into different possibilities. It will depend on a lot of parameters, depending on the local conditions, like the price and the quantity of feedstock, and the local needs in terms of energy or electricity, hydrogen, methane, and of course the price of these outputs. So depending on the level, the type of feedstock we get, and the energy and molecules that are required locally, we adjust and we choose the best business model. Third element, the waste management has a lot of constraints in terms of regulations. These regulations are more and more strict, and it is good. And one main principle in waste management is the waste treatment hierarchy. Producing energy is better than landfilling, of course, but even better than that, there is the chemical recycling, when we can't do mechanical recycling because the waste are too mixed, for instance. And as you have understood, the pyrolysis is part of the technology to do chemical recycling. So last element, pyrolysis is part of chemical recycling technology, and it allows to go up in the waste treatment hierarchy. So after these first three main elements on valorization of waste, just briefly, I want to present our technology. I will not be very long on that because it was part of the first webinar, just as a reminder. So our main technology is named SPIRAJOULE. It consists mainly in a screw with a hollow shaft, and this screw is heated by electricity going through it with the Joule effect. So the product temperature is precisely controlled by the heating screw temperature. We also control perfectly the dwell time by the regulation of the screw rotation speed. So we have more than 150 units in the world based on this technology, of which 40 for pyrolysis. It is simple, robust, and above all, it is precise, continuous, and homogeneous, all the conditions required to get high-quality final products. So, and in real life, you can see there how it looks like. So now we will go through 4 business cases in order to illustrate these elements. So we'll go through sewage sludge, end-of-life tires, non-recyclable plastics, and a little bit different, how we can improve the recipe of feedstock with artificial intelligence. So first, the pyrolysis of sewage sludge. Sewage sludge are becoming more and more an issue in a lot of countries. One of the main valorization of sewage sludge is through spreading these sludges in the fields as a fertilizer. However, it implies many constraints, problems of odors, possibility to spread only in a part of the year, issue of storage, and more the fact that sludges can contain some pollutants like heavy metals become a big and bigger issue. Moreover, it is a very wet product if not dried, and drying is very energy intensive. So another valorization can be incineration, but it does not turn the waste into value, but rather into a high cost. So what pyrolysis can do, what can pyrolysis can do for sewage sludge? You can see on this slide that depending on the temperature, we will produce at low temperature mainly a solid, we can call a BIOCOAL here, or a gas at high temperature. For our business case, we have chosen to produce at a low temperature in order to produce a high percentage of BIOCOAL. And so this business model is illustrated here. So the municipality, which in this case is in Japan, they have more and more issues with sludges. So a company, which is our local partner, sells BIOGREEN, the SPIRAJOULE, our equipment, to the municipality to treat its sludges. These sludges are turned into BIOCOAL, and the company commits to buy back this BIOCOAL. And why the company is interested by this BIOCOAL? It is because it can use this BIOCOAL into coal plant to produce electricity. And they can benefit by doing that of a very interesting feed-in tariff, because the BIOCOAL is coming from a biogenic feedstock. So it is a win-win-win situation, both for ourselves, the company, and above all, the municipality. But we can do another business. So here is some photos of our first industrial plants in Japan, 10 days per 10 tons of sewage sludge per day. Here, it is another business model for sewage sludge. And the objective there is to treat the sludges at a higher temperature, between 700 degrees Celsius, in order to produce enough SYNGAS to dry the wet sludges. To dry wet sludges, it is very energy intensive, but very often we use some natural gas. In this situation, instead of natural gas, we will use SYNGAS, so it will avoid a lot of consumption of fossil fuels. And so after, we can get a little bit of biochar, of BIOCOAL, sorry, to be valorized in different ways. Second business case, it is how we can give a second life to the so-called end-of-life tires. And more than that, to create a product that can be reused in the manufacturing of new tires. It is what we are doing in UK with our partner, Mark Murphyt, which is recycling more than 100,000 tons per year of end-of-life tires. To give you an idea, there are 2.5 million tons of end-of-life tires in Europe, and many more in US and Asia. So the objective is to transform these end-of-life tires into energy and RCB. RCB means recycled carbon black. RCB is one of the main raw materials used to manufacture tires. There are a lot of different types of RCB depending on the physico-chemical parameters, and these parameters are very key to meet the requests of the manufacturers, with a lot of parameters like surface area, porosity, structure level, surface activity, and many more. And what we have achieved with our partner is to create a whole process able to produce a very high added value RCB, filling all the requests of the manufacturer. So this process is based on 4 steps. First, the recycling part, which is managed by our partner with some specific features. The second one is the pyrolysis of the biochar part, of the rubber part. The third part is energy conversion in order to benefit for the SYNGAS for a heating network in this business case. And the last part is the char processing. This last one consists of a kind of second step of refinery of the char produced by the pyrolysis, and is very essential to meet the key specifications of the manufacturer. So for the manufacturer, it is a lot of advantages. They have significant energy and recycling savings and some substantial environmental benefits, like a reduction of the carbon footprint, and reliable and sustainable recycling of end-of-life tires, avoiding to get this waste spread in the nature. So it's really the development of a real of a circular economy, tires coming back to tires. The third business case is plastic to X. So as you know, there is a huge quantity of plastics that are not recycled, 220 million tons per year. So plastic to X means that we will turn these plastics into different products depending on the local business model. X can mean, for instance, SYNGAS to be used as a fuel for industry or produce electricity. It can mean also a crude oil that can be upgraded into different chemicals, or it can be methane or even hydrogen for industry or mobility, and also pure carbon, which is a solid carbon that can be used in different parts of the industries. So a first example is plastic to electricity. We are working on this business case with Race for Water, an NGO fighting against pollution in the oceans. To do that, they want in particular to develop a solution for the islands that have a lot of plastic on their beaches. At the same time, the production of electricity in these islands is often done through genset using diesel at a very expensive price. So the business model here at the bottom right, you can see it there, is to turn plastic into electricity to replace the genset, and at the same time to be able to pay the guys to go to collect the plastic on the beaches. If they are not paid, will not go to collect this plastic. So we have to find there a business model that can generate some money, some profits, in order to pay these guys to collect the plastics. In Europe, for instance, this business model can't be the same. So as the price of electricity is much more competitive, for instance, in Europe, we have to find higher values in terms of products. So these products can be methane or hydrogen. I particularly like the hydrogen pathway. Actually, plastic is a mix of carbon and hydrogen. And so to cut these molecules, we need to do a pyrolysis at a very high temperature, more than 1000 degrees. And the more you heat, the more you cut this molecule, and so the higher is the rate of hydrogen. And the beauty of that is that the output of both hydrogen, that is very valuable product to do, for instance, mobility or without emitting greenhouse gases, and some carbon at the same time that remain as a solid, so a carbon sink. In a nutshell, we can produce energy with a fossil raw material, the plastic, without emitting greenhouse gases. It is what other industries try to do with carbon capture storage, for instance, but this solution needs some big underground cavity. And these cavities, we can't find them everywhere. The solution we present can be rolled out in all local authorities with production of hydrogen at the local level. And so we have different projects ongoing on these subjects. The last business model I want to speak about is a little bit different. It's how we can use artificial intelligence for waste sorting. So this is done by our subsidiary Ascodero that is specialized in robotics. So the objective there is to enhance the quality of the recipe of the feedstock we want to valorize. If we want to produce high added value output, we need to get the higher quality of a feedstock. And very often the quality of the feedstock is good, but could be far better if some small percentage of pieces are removed from the main part. And unfortunately, human beings cannot sort the waste up to a certain level, up to the level required, and certainly not to 100%. Only technology can do that. So we have developed a specific waste sorting system with artificial intelligence and robots in order to identify the pieces to be removed, to take them very quickly, and to remove them efficiently. So the identification part is done through visualization with artificial intelligence in partnership with PIGVISA. PIGVISA is an innovative technology company that provides industrial solutions based on image processing and machine vision. So we have particularly worked up to now on recognition of some metals, and we are developing new solutions for sorting centers for organic waste. So I have finished now my presentation. I hope you're still there, and we can now answer to a few questions. And so if you have more questions and we have not time to answer them now, do not be afraid. Send us an email, and I will be very happy to build a solution with you with a profitable and sustainable business model. Thanks.